All right, so good day to everyone. Thank you for joining us today for Solidus 2022, Accelerating Product Development for Consumer Durables. And my name is Engineer Reynaldo Luis III. I'm the Business Development Officer of CIM Technologies Incorporated, Philippines. First, let me discuss our agenda quickly. First, we'll talk about the key challenges for product development of consumer durables, then the solutions for those challenges and what's new in Solidus 2022. Then some case studies on how Solidus helped and improved their processes. Then a summary. Then we'll wrap up the presentation by a question and answer portion. First are the key challenges. Here are some of the key challenges for product development we have identified talking with designers and manufacturers of consumer durables. We'll look at these challenges in more detail and look at how using Solid Edge to create and reference a digital twin of your product helps you meet these challenges. Okay, so the first key challenge that we'll discuss is for collaboration. So collaborating with customers and suppliers, of course, you need to collaborate quickly and easily with suppliers and customers. Then share multi-CAD design data in a controlled way while protecting intellectual property. Next is managing projects and changes. So you need to manage data that's created and consumed throughout the product lifecycle. Then manage engineering changes efficiently. Then manage release to manufacturing. Then last is managing customer and regulatory requirements. Ensuring that the device, as delivered to the end user, meets the requirements and complies with industry regulations. All right, so the next challenge is for mechanical design. So design plastic enclosures and housings. So consumer products often use plastic components for enclosures, housings, handles, covers, etc. And then design plastic components quickly and accurately. The design sheet metal enclosures. So design sheet metal components including enclosures and housings for power supplies and electrical components. Faster 3D mechanical design. So create complex designs quickly and accurately. We use proven components and catalog parts where possible to speed design. All right, so under electromechanical optimization, first challenge is designing electrical wiring circuits and assembly harnesses. So of course, design electrical wiring schematics, wire harnesses, and control panels quickly and easily. Select optimal wire gauges and fuse ratings. Next is electromechanical design, routing wiring around electromechanical assemblies. So of course, routing electrical wiring around systems with limited space is increasingly complex. And you need to avoid hotspots and moving components. Next is simulate performance using virtual prototypes. So you need to optimize product design efficiently using virtual prototypes. Minimize the cost and time required to build physical prototypes. Last is analyze cooling and power sources and components. Electronic components and power supplies act as heat sources. So you need to ensure heat is dissipated adequately and that hotspots are within allowable parameters. Okay, for the last key challenge is for manufacturing and documentation. So manufacturing accurately and efficiently. Minimize the cost and time required to build physical prototypes and manufacture small volume parts efficiently. Then manufacturing accurately and efficiently. Errors and rework in manufacturing, choosing the best manufacturing process, taking advantage of new manufacturing technologies. Then create manufacturing instructions and end-user manuals. Ensure that consumer durables are manufactured and used correctly to ensure performance and reliability. Create attractive visualizations for sales and marketing. Improve communication of design to prospective customers and communicate the unique value of innovative solutions. All right, now let's take a look on the solutions and what's new in Solid Edge 2022. Our first solution is for collaboration. Okay, first is data management. So here are some of the challenges for data management So need to manage data that is created and consumed throughout the product lifecycle, manage engineering changes efficiently, and manage release to manufacturing. So how can we help? Data management capabilities built into Solid Edge, including revisions and release management capabilities. Road Path Team Center for comprehensive PLM capabilities. So what are the benefits? Fast and accurate completion of projects and engineering changes, and speed introduction of new products. So next is requirements management. So the challenge, ensuring that the device as delivered to the end user meets the requirements and complies with industry regulations. How can we help? Provide easy-to-use tools for capturing customer requirements and making them easily accessible to all involved in product development. Then, link customer requirements to design projects and 3D CAD models. So the benefits? Reduction in costly rework when device does not meet customer's requirement, and improved customer satisfaction. Then we have accelerator share, augmented reality, messaging and notifications, any device, instant on access, multi-user, override protection, connection to Team Center. So how can we help? So easy to use cloud-based collaboration tools for sharing of multi-CAD data with suppliers and customers, and integrated visualization, markup, and augmented reality capabilities for multi-CAD data. Let's take a look at accelerator share. For CAD files, there is an integrated 3D view environment where you can hide and show parts, explode assemblies, section, measure, and markup. This is great for manufacturing and design reviews. So here, we're identifying the need for some changes with the markup and some text annotations. Accelerator share offers maximum traceability as all markups are recorded, enabling a conversation back and forth on any of the issues you're tracking. It records who made any markup, and when it was made, we can also easily go back to the markup at any time. With Share, you can also connect your CAD, synchronizing your data from your desktop to the cloud. Here we have the same coffee machine project on our desktop, represented simply as a folder. Any data that we have in the folder will get synchronized in the background. In Solid Edge, we can securely sign into Accelerator, share and see those some cloud-based projects. The espresso machine can be opened and we can get right to work on the part in question. The designer can easily access these same markups in the cloud directly from within Solid Edge. And then, of course, go ahead and complete the work, which in this case is to add a cutout to the leg of the espresso machine. Once completed, another markup continues that two-way conversation and collaboration with other stakeholders on that issue are tracked appropriately. Another great capability is sharing projects with anyone. Simply enter the email address of the person that whom you'd like to share and choose their access permission level. Here, we can choose view or view and download, or edit and download depending on how we want to protect our intellectual property. We will share this design with one of our colleagues and our customer and give them appropriate access. Finally, with the Share's augmented reality functionality, we can see exactly how our design will look in a real-world environment. It will snap the design onto any surfaces that are seen through the camera lens and the correct scale. The finger gesture can be used to manipulate the model and easily visualize what the design looks like in the real environment. The ability to collaborate effectively is an increasingly important area today, as traditional supply chains are now under pressure from an uncertain environment around tariffs and from global health concerns. Examples of collaboration can include working with a customer who is in a different location to review the design of a component, or work with the manufacturer of mold tooling to investigate an issue you have encountered in the manufacturing process. Siemens has easy-to-use cloud-based collaboration tools that enable you to share design data that was created in different CAD formats with customers and suppliers. And this can be done in a way that protects the intellectual property of your designs. So the benefits, Accelerator Share reflects the three key SaaS benefits: accessibility, flexibility, and scalability. Faster and controlled communication of design intent with suppliers and customers reduced errors, and speed up the production development process. Next solution is for mechanical design. For parts and assembly design, so the challenges: create complex designs quickly and accurately, and reuse proven components and catalog parts where possible to speed design. So how can we help? Comprehensive, proven 3D CAD that makes design accelerating and more efficient. Reduce design time and eliminate design errors before manufacture, and incorporate proven components and catalog parts quickly and easily. So the benefits, so it can speed up the design, make changes accelerating and increase reuse of existing components, and deliver new products sooner and with lower business risks. Then for plastic part design, so the challenges: electronic devices often use plastic components for enclosures, housing, handles, and covers, and design plastic components quickly and accurately. So how can we help? Create plastic features including thin walls, bosses, vents, lips, ribs, web networks, and embossing, and draft face analysis to help prepare parts for molding processes. Then the benefits: speed up design, make changes, accelerating and increase reuse of existing components, and deliver new products sooner and with lower business risks. Then for sheet metal design, the challenge: design sheet metal components including enclosure and housing for electric components. So how can we help? Industry-leading sheet metal design and detailing. And of course, engineers can produce accurate flat patterns from the 3D digital model and send the geometry directly to manufacturing. So the benefits: streamlined sheet metal design and manufacturing that reduces cost and speeds delivery. And new in Solidage 2022 for subdivision modeling, Convergent and CAD Direct. So for convergent modeling, Solidage now supports mixed mesh modeling, or also called as hybrid convergent modeling. So mesh and classical faces in one body. So for CAD Direct, an ability to insert foreign file formats into Solid Edge assembly, useful for supplier collaboration, avoids the needs to translate files separately, and associative update when parent files changes. Complex shapes are created even faster with the addition of great new enhancements in Solid Edge as shown here in our espresso machine. The new bridge command effortlessly connects edges or faces of subdivision cages and creates a lofted structure between them. To further refine the shape of the part and have it match the outward curve of the machine, we'll use the new Align to Curve command. Simply select the cage vertices, define the direction, and pick the curve. During this process, it's possible to manually define a spline curve or even use gestures by clicking and dragging to fluidly adjust the form as required. Split with offset is another option that greatly speeds up the process of adding detail to a face by offsetting it inwards. This allows us to push the resulting faces to create some cutouts for the rubber feet on the machine. Now we'll replace this handle with a new design that has been 3D scanned. This results in a mesh model that we'll import. We can visualize the mesh with a new View Facet Edge command. In this case, we'll clean it up a little by remeshing it. After automatically identifying the regions of the model, we can start sketching directly on the planar faces that have been recognized. As we add a series of cutouts in order to reduce the weight and improve the appearance of the part, notice that the resulting geometry isn't faceted. Solid Edge now seamlessly combines mesh and B-rep geometry in the same body or part. Here some rounds have been added. So we'll add additional cutouts to reduce the material in this area. Once the cut is complete, it can be patterned. Again, notice the resulting geometry isn't faceted. We're doing all this on a mesh model without the need to fully reverse engineer it. Back in the assembly, we can swap out the old handle for our new design and see how it looks. We're missing a new mounting holes to finish the part. This can be easily resolved by using a geometry of existing components to subtract the material directly from the mesh model. These new capabilities further enhance the ability to use mesh models in the design process. The new CAD Direct command enables the use of foreign parts and assemblies in Solid Edge without requiring any translation. The water boilers being added here were designed in NX. Once inserted into Solid Edge, they can be positioned just like any other assembly. Since we need two of this, we'll simply copy it into place and automatically constrain it. Unfortunately, the boilers don't quite fit our design. They need to sit lower down. Going back to NX to fix the issue, we can make a change to the mounting bracket to make it longer, then save the assembly. Since Solid Edge continually references the NX assembly, a simple update brings the changes for us. So here are other benefits for subdivision modeling, Convergent, and CAD Direct. So new built-in 3D design capability improves productivity when working with geometry from popular CAD systems. Inserts files directly into a Solid Edge assembly without the need to translate the file separately, maintaining associativity. Unique hybrid models capabilities allow B-rep and mesh geometries to coexist in the same model for downstream assembly use. Speeds workflows, making mesh models even more useful, and significantly reduce modeling time. Now, for the next solution is for electromechanical optimization. Okay, so first it's for Solid Edge wiring design. So here are the challenges. So design electrical wiring schematics, wire harnesses, and control panels quickly and easily. And select optimal wire gauges and fuse ratings. So how can we help? Software for fast creation of data-driven wiring schematics and control panel layout, and validation of correct functioning of electrical circuits as they are designed. So the benefits, we can quickly design wiring circuits and wire harnesses, and key attributes of electrical circuits, including wire gauges, fuse ratings, and open and short circuits are checked during the design process. Next is for Solid Edge routing. So here the challenges are routing electrical wiring and wire harnesses around systems with limited space is increasingly complex, and packaging PCBs is in confined spaces. So how can we help? Semi-automatic routing of wiring and wire harnesses around complex 3D models. Establish correct wire lengths and integrate PCB designs into electromechanical assemblies. So the benefits? Minimize need to create physical prototypes to reduce problems in installation and operation of wiring, and integrate PCB designs into electromechanical assemblies quickly and accurately. For structural and flow simulation, so we can help by integrated simulation tools including static, dynamic, and fatigue analysis, and integrated fluid flow and heat transfer analysis. So the benefit? Significant drop in cost and in time to delivery as engineers optimize products and identify and resolve problems before manufacture. For thermal simulation, so the challenges, electronic components and power supplies act as heat sources and need to ensure heat is dissipated adequately and that hotspots are within allowable parameters. So how can we help? Integrated simulation of electronic power sources and heat dissipation. And the benefit? Ensure heat is dissipated correctly and hotspots are kept within allowable limits. CIM Center Flow EFD for Solid Edge is a computational fluid dynamics or CFD application that is integrated with Solid Edge. It includes heat transfer analysis capabilities so engineers can simulate cooling of heat-generating components. In addition, the Flow EFD Electronic Cooling Center has a more comprehensive set of capabilities for analyzing cooling of electronic components. Up next is for manufacturing and documentation. For additive manufacturing, the challenge is to manufacture small volume parts efficiently and minimize the cost and time required to build physical prototypes. So how can we help? So prepare parts for manufacturing on in-house 3D printers and access a cloud-based bureau for additive manufacturing of parts in a variety of materials. The benefits, significant drop in cost and time to deliver as engineers optimize products and identify and resolve problems before manufacture, and minimize need for large stocks of spare parts. For create manufacturing instructions and end user manuals, so the challenge is communicate design and options to prospective customers, and communicate correct manufacturing processes to shop floor operatives, and ensure that products are installed, used, and maintained correctly to ensure performance and reliability. So how can we help? So create interactive 3D technical publications that clearly communicate the correct manufacturing process. Create clear documentation that helps end users use and maintain products correctly. And create online catalogs that presents products, options, and spare parts to customers. So the benefits, product is manufactured, installed, and maintained correctly, ensuring it performs as designed, and increased revenue from spare parts. Create attractive visualizations for sales and marketing. The challenges need to improve communication of designs to prospective customers and needs to communicate the unique value of innovative solutions. So how can we help? Fast and easy creation of 3D digital models, photorealistic images, and animations, and augmented reality to show product in real-world environment. So the benefits, it creates attractive marketing materials and catalogs easily and quickly. It also creates custom marketing materials and clearly demonstrate new innovations and use of latest design technology. Now, for manufacturing operations. So here are the challenges. So errors and rework in manufacturing, choosing the best manufacturing process, and taking advantage of new manufacturing technologies. So how can we help? Create machining toolpaths and simulations based on digital models, and work with different CAM solutions while creating toolpaths that are associative to the CAD model, and create interactive work instructions. The benefits, it reduces errors and rework in manufacturing, faster manufacturing process, and designs optimized for manufacturing. Solid Edge CAM Pro is our solution for creating toolpaths for machining operations. Toolpaths for Solid Edge CAD models can also be created using most of the third-party CAM software solutions that are available. Next up is something of real excitement. So we are now including fully functional 2.5-axis milling capability in our Solid Edge Classic, Foundation, and Premium products for customers who are on active maintenance. So here's a preview of its capabilities. With Solid Edge CAM Pro 2.5-axis now included with every Solid Edge license, let's explore the powerful yet easy-to-use tools with the Fiyama coffee machine as our example. We'll leverage Solid Edge CAM Pro to create the manufacturing toolpath for the machine's rear legs. First, we'll use the Solid Edge assembly tools to create the shape to represent the stock part, and also the parts that's from the fixture assembly, which include the stand-off plate we see here. As we add additional fixing holes from the standard database, we'll also make use of the vast supplier catalogs in 3Define It to get an appropriate socket head cap screw. We're seeing that Solid Edge is a great CAD for CAM tool, but also that the Solid Edge CAM Pro solutions handle assemblies as well as single parts, which is very important when creating toolpaths and making sure to avoid collisions with the fixture components. We'll machine the design in two setups. Step 1 is to mill the pocket and drill the holes. Step 2 is to machine the profile. One click sends the entire assembly to Solid Edge Cam Pro. Associativity is maintained to the complete assembly. So if there are any last-minute changes, we can quickly accept them and continue the NC programming process. New for Solid Edge Cam Pro is the ability to create adaptive roughing toolpath for 2.5-axis operations, included at no additional cost. These are faster than traditional toolpath and extend the life of the cutting tools. Solid Edge Cam Pro also has great visual tools to build your confidence. Here, we're using toolpath animation with material removal to see the cutting effect. Built-in productivity tools like right mouse button context menus allows a user to sail through the NC programming process. Here, we'll create a spot draining operation for the 5 holes in the support. Notice the graphical pop-up hints that help us with operational selection. Graphical helps are also available in geometry selection. Each time we select a hole, we get a preview of the machining that will take place. At any point in the process, we can get visual feedback in our decisions. Now that our CNC program is complete, let's run the whole thing through visualization before post-processing. Pocketing, profiling, and hole making, Solid Edge Cam Pro can do all that and much more. No CNC job is finished until it has been post-processed for a specific machine. That's where PostHub, an online database of more than 1,200 post-processors, really shines. You can filter using several different criteria to find exactly the one you need. PostHub is also constantly being updated with new posts. As you've just seen, CamPro 2.5-axis annealing allows users to maintain full associativity with design data, while instilling confidence with automated toolpath creation and visualizations for optimized machining processes. And it's fully integrated with Solid Edge. So the benefits, it reduces errors and rework in manufacturing, faster manufacturing processes, and easily search for vector components with integrated and intuitive tools. New in Solid Edge 2022 is dynamic visualization. Dynamic visualization provides interactive access to document properties based on report containing rules. Rules are easily built with MS Excel, like filters within interactive tables. Interactive user-defined tables with sort and Excel-like filters. Color display of your query results. Create rules easily from filtered tables. Fast indexing of properties while assembly loads. Export reports to be shared with other users and other attendees. And support for standard and custom properties, as well as in-session status such as modified since last save. Turning our attention to Solid Edge built-in data management functionality, we can see that dynamic visualization is available here too. With dynamic visualization, we'll perform a quick material check on our Fiamma Espresso machine to confirm the right materials are assigned to each part. Once the report has run, we can see an issue. So the 2 small handles at the rear of the design are color red, indicating they are currently defined as aluminum, but they should be green in this case, signifying they are stainless steel. To correct this, we'll ask the design team to revise the handles and correct the material definition. The updated status info command forces an update on our design and retrieves information, including the new revisions. The Pathfinder then clearly illustrates the revisions are available. The get latest command then provides a visual cue to users working in a collaborative environment and allows us to update the assembly by replacing the older versions with the very latest. Running dynamic visualization again allows for a quick visual check and ensures everything is now in order. A modernized, powerful file property dialog makes it even easier to search for, maintain, and manage document properties and metadata. We can filter the information to only show the editable properties and add new ones. In this case, a new custom property to define the finish for the handle. The newly added 3D Find It and replace part with 3D Find It commands allows users to streamline the process of finding 3D components by searching supplies catalogs for parts that are similar in shape to the selected model. We can see this in action here as we look for alternatives to the rubber foot. Once we have chosen the replacement part, we can change the parameters if needed, and then, at the click of the button, replace it in our assembly. The ability to use Pack and Go directly from Windows Explorer saves time if the desired assembly isn't already open. For dynamic visualization, it quickly accesses important design data using flexible rules and build customized visual reports easily using interactive tables. Now let me present to you some case studies. Group SEB's industrial policy aims to serve markets in the best possible way by continuously improving competitiveness and quality standards with a view to the long term. With an in-house manufacturing base that is unique in its industry, Group SEB skillfully combines global industrial power with proximity to the consumer markets. Brands including Molinex, Rowenta, WMF, Crops, each brand has a well-defined identity with the specific values which are reflected in the product offering, features and design, as well as in appropriate communication mechanics. So their challenges: shorten time for launching new products to market, transition local product development to cross-discipline processes, and align processes across more than 20 brands with multiple industries and geographies. So the solutions: Solid Edge supports multiple CAD and ERP tools, implement standard PLM data model that meets the needs of each Group SEB business, and delivering high-level business knowledge while formalizing integrated cross-discipline processes. So the benefits: increased new products by 43% from 140 to 200. Increased processes reliability and standardization of policies. Capitalized on project know-how by making PLM tools accessible across the entire workforce. From Oliver Gomas, the head of PLM Information System Department from Group SEB, using Siemens PLM software technology, we've increased new product introductions by 43% annually, from 140 to 200. Next is Grossmann from Germany. So they build luxury watches. So their challenges: fast development and production of luxury watches, building a team of qualified craftspeople, and earning a distinction of being a Glashütte watchmaker. So the solutions: establishing a team of qualified and ambitious employees, use a state-of-the-art tools for design and manufacturing, and excellent detail or precision execution. The benefits: presented and successfully launched first watch model, designed and launched 3 new watches in several variants, and reduced design time to enable more innovation time. So from Jens Schneider, the chief designer of Grossmann Uhren, using Solid Edge, I can handle the many changes and variants that occur in the design process much faster than in the past. The possibility to model parts within an assembly, as well as the integrated data management functions, offer a big advantage. Next is Kimball International Inc. Kimball provides a variety of products from 2 business segments: the Electronic Manufacturing Services segment and the Furniture segment. The Kimball Electronics Group provides engineering and manufacturing services which utilize common production and support capabilities globally to automotive, industrial, medical, and public safety markets. The Furniture segment provides furniture for the office and hospitality markets sold under the family of brand names Kimball Office, National Office Furniture, and Kimball Hospitality. As with any company that adapts well to change, Kimball's flexibility and versatility allows to stay in front of business challenges, including the ever-changing office environment, along with escalating indirect and direct costs of running a responsible global country. In 2008, Siemens PLM software launched Solid Edge with synchronous technology to enable users to accelerate new design processes, make faster changes to existing design, and improve the reuse of imported data. Kimball moved to Solid Edge with synchronous technology to address its business and engineering challenges. You can become more productive, you can enjoy more of what you're doing, says Espinosa. When you work with traditional CAD, product engineering work becomes very repetitive. With synchronous technology, you can participate more in the design process, the fun side of developing products. There's a nice return of investment when adopting synchronous technology, but our main reason for implementing the tool is to be more productive, design better products, get to market faster in the design process. Kimball moved to Solid Edge with synchronous technology to address its business and engineering challenges. You can become more productive, you can enjoy more of what you're doing, says Espinosa. When you work with traditional CAD, product engineering work becomes very repetitive. With synchronous technology, you can participate more in the design process, the fun side of developing products. There's a nice return of investment when adopting synchronous technology, but our main reason for implementing the tool is to be more productive, design better products, get to market faster, and create an easier process to leverage legacy data. From Ricardo Espinosa, Engineering Service Manager of Kimball Furniture Group. Alright, so there are three key takeaways for today's presentation. So first is to overcome your business challenges with our targeted solution. Second is win against competition thanks to unique differentiators. And third, reduce time to market and costs, increase productivity and profits. Thank you everyone, and we'll see you back at the general session for the Q&A.